Hey everyone, welcome back to Take You Forward. We will be starting off with a new pattern that is DP on strings. Okay, generally in DP on strings, you will find problems of comparison, you'll find problems of replacements, edits, etc. So these kind of patterns is what we will be solving, and we'll be doing a bunch of problems. And again, when we complete DP on strings, you can solve any problem on DP on strings. That's my guarantee. So to start off with, let's take the first problem, which is longest common subsequence. Yes. But if you're understanding that, let's understand this term subsequence in depth. What is subsequence? So if I write ABC, A is a subsequence, B is a subsequence, C is a subsequence, AB is a subsequence, BC is a subsequence, AC is a subsequence, ABC is a subsequence, empty string is also a subsequence. What is a subsequence in a string S? You see BC, repetitive, BC is consecutive, and maintaining the order of B and C, maintaining the order of B and C. You see AC, AC is not consecutive, but maintaining the order of AC. ABC is consecutive and maintaining the order. Very simple. It can be consecutive, it cannot be consecutive, but as long as it maintains the order, in the string, then you can call it as a subsequence, right? And in order to print all these subsequences, you might be thinking, Striver, how do I print all the subsequences? So in order to print all the subsequences, you can use either power set, I have a video on this, or you can use the recursion method. Again, I have a video on both of them. And if you watch the video, for any given string, like this string is of a length 3, and the number of subsequences is 8, including the empty one where I say I do not pick any one. So for a string of length n, the number of subsequences is 2 to the power n. Okay, so that is what subsequences mean. So what is longest common subsequence? What does this signify? What does this term signify? So I can say over here ADE is a subsequence, ADB is a subsequence, AEC is a subsequence, DBC is a subsequence, EC is a subsequence, DC is a subsequence. There can be 2 to the power 5 subsequences, 32 different subsequences. Similarly over here there can be 32 subsequences. Okay, so I can say this guy can generate 32 subsequences, namely A, D, E, B, C, A, D, A, E, A, B, A, C, and so on. And this guy can also generate 32 subsequences, correct? Namely D, C, A, D, B, D, C, D, C, D, A, D, 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 B, and so on. Now what you need to do is, you need to take this A. Does this A exist? Yes. So as of now, the common subsequence, one of the common subsequences is A. Does D exist? Yes. One of the common subsequences is D. Does AD exist? No. So AD is not a common subsequence. Does AC? No. Does AB? No. Similarly, you have to go on writing and you will see ADB exists over here, ADB, and ADB also exists over here. So you'll find ADB is common in both of them. And you have to find among all common subsequences, which one is the longest. So ADB is the longest that you'll find. Yeah, there was A, there was D, but you need the longest. So the longest is ADB. And what is the length of this? 3. The length of this is 3. So you need to tell me the length of this, which is 3. So that's the question. Pretty straightforward. Now you might think, Striver, let's apply brute force. Okay, that's correct. What's the brute force? Generate all the 32 subsequences. Generate all the 32 subsequences on this side, and then do a linear comparison of both and find manually which one is the longest. But in order to do that, you have to actually generate all the 32 subsequences, because generate, take one, compare, take one, compare, take one, compare, take one, compare, and get the longest among them. So that's going to be 2 to the power n, because you have to generate all of the subsequences, exponential in nature. So the brute force is going to be exponential in nature. Hence, a pattern that I will not follow. But yeah, if you want to generate all the subsequences, feel free to watch out the power set video or the recursion video that I will be leaving the link in the description. Okay, so if not brute force, then what? Then my brain says, okay, let's generate all the subsequences and try to do comparisons. Okay, generate, that's what we did. Generate all subsequences and compare on way. That's what I'll think. And that's a standard way. Like you have to generate all subsequences and compare on way. That's a standard way that we generically do in a recursion, or like, and on DP on strings. I'll be telling you about that. So you will be tending to follow a recursion method where you will not generate these. Instead of that, you will use parameters to generate them. I'll be showing you how. So first, let's understand something in deep. Let's take an example super quickly. ACD and CED. Okay, assume these are the two strings that you're looking to solve. ACD and CED. Okay, now if you go to generate all the substrings, it will be ACD, ACAD, CD, ACD, and over here it will be CED, CE, CD, and ED, CED. Then you figure out the longest being CD and CD. So thereby this is the longest, which is of length 2. But if you generate this, that doesn't make sense. That's where we will try to write some recurrence. Yes, we'll try to write some recurrence that probably gives me the answer through the way. Through the way is my question. Okay, so assume you're solving this entire portion, this entire string and entire string. Okay, and generically, what are the rules to write the recurrence? Let's quickly just jot down the rules to write recurrence, and then we will try to follow those paths. Express everything in terms of indexes. Explore possibility on that index. That's it. Explore possibility on that index is what we do. Take the best among them, because you're looking for longest. Take the best among them. These are the 3 rules that you generically follow. Now, express everything in terms of index. Okay, so either you can carry this entire string, or you can say, hey, listen, probably I can have a pointer here. Let's understand. Probably I can have a pointer here, which is somewhere around index 2. And f of 2 signifies the string till index 2. Okay, probably you can say I can keep a pointer here, which is again index 2. F of 2 again signifies the string till index 2. Something to observe. A single index cannot express both the strings. A single index cannot express both the strings. Thereby, I will have to represent them by 2 indexes. I have to represent them by 2 indexes, where index 1 represents this guy, index 2 represents this guy. That's the first modification that you have to do in the rules. Since you're dealing with couple of strings, you express them in terms of index 1 and index 2. Very simple. Like in all the array problems, you expressed everything in terms of index, because there was an index. Then you decided to pick, not pick, or similar kind of things you did. Over here, we will have index 1 and index 2, which will be representing. So can I say, if I omit this and I write this something as f of 2 comma 2, or rather let's write it in a smaller way, f of 2 comma 2, what does this represent? Tell me the LCS of string 0 to 2, string 1 0 to 2, and string 2 0 to 2. This is what this f of 2 2 will represent. So we have understood the expressing term. We have understood the expressing term. That's done. if I'm writing something as f of, let's say, 2 and 5, what does this signify? This signifies give me the longest common subsequence between string s1 0 to 2 and string s2 0 to 5, a smaller string and a larger string. This signifies this. So I hope you have got an idea what I'm meaning to say by index 1 and index 2. Okay, so this we have figured out. Now time to explore all possibilities, because if you do not explore all possibilities, we will be having an issue. Okay, so let's try to explore all possibilities. Okay, let's try to write them. So can I say this? That, okay, Strivalus, I'm having the string ACD and CED, and I'm having couple of pointers over here, and this is index 1 and this is index 2. So a very straightforward question is if they're matching, because this D, like, do comparisons character wise. Remember this. Do comparisons character wise. So this D and this D is matching. That's something we can see. This D and this D is matching. So can I say, if I just do not think of these things, and this D and this D is matching, can I say I got a subsequence of length 1? I got a subsequence of length 1, that is D, which is common in both of them. Again, makes sense. Thereby, I can probably say one of the possibilities that I can have is I got one subsequence of length, and then I shrink the string. Then I shrink the string and say the new string is AC and CE, in which probably you can find an answer. So, does that make sense? It does. Because if these guys are matching, now you just have to take these two strings and you have to ask them, what's the longest common in them? Because I've done for D, which is 1. What is AC? I said you what is AC. This index will come here, which is index 1. So I can say AC is index 1 over here, CE is index 2 over here, which is nothing but f of 1 comma 1. F of 1 comma 1. Why f of 1 comma 1? Very simple. Because 1 for this T, and I've shrink the string. This is the string, so that's f of 1, which means 0 to 1 is the string, and this D you took, so again 0 to 1, so f of another 1 is there. That's how you can do it if they are matching. So if character matches, index 1 matches with index 2, can I write this as, I will add 1 to the answer and I will reduce index by 1 and the other index by 1 as well. Can I say this? I'll reduce index 1 by 1 and index 2 by 1 as well. And this is going to be the recurrence if both of the guys are matching. Okay, so we have probably done one possibility. We have done one possibility over here, which is if both of them are matching, then it's kind of very simple enough. You say 1 plus f of index 1 minus 1, index 2 minus 1, and that's going to be the case if match on indexes. That's one possibility. Okay. Now what about the other possibility? Because what if they do not match? Because in all the string problems, in all the comparison of string problems, you'll see match and not match. Match and not match. In previous problems of arrays, it was pick, not pick. Over here it will be match, not match. So for matches, you'll generically add to the answer and it'll move back by index. In matches, you'll generically add the answer and move back by index. Similar to pick when you moved one back. Okay, so what about non-match? Let's talk about non-match. What if they're not matching? Yes, what if they're not matching? Because in the next step, it will be AC and CE. What if they're not matching? Let's see. If I have AC and CE and they are not matching, something I know for sure is, if I go ahead, this C will match with this C. But as of now, my index 1 is standing here, my index 2 is standing here. So, how will I go and compare this C and C? Because as of now I'm standing at E. If I move them both back, I will miss out on a comparison of C. I'll miss out on a comparison of C, right? Or what if there was an E here? So this E would have matched with this E. So I can also miss out on a comparison of EE as well. You understand? If I write EC, then what will happen? This C and this C might match because they're standing in the other places. Or this E and this E might not match any day because they're standing at opposite, standing at different places. Thereby, you have to apply your brain. Thereby, you have to apply your brain in such a way that you explore both the possibilities. Yes. What are the both the possibilities? You say, hey, listen. For example, let's just to understand, let's do it easy. You will say, hey, listen. Let's do one thing. Let's move only one guy. I will like, okay, but which guy? Let's try both. Because in both the directions, you might find the answer. I'll be like, okay. I'll be like, okay. This C did not match with E. Did not match. But this E might match with this E. I'll be like, okay, this C did not match with E. But this E might match with this E. Let's do one thing. Let's move the index 1 only. Let's keep the index 2 as it is. And since they're not matching, the answer added to the longest will be 0. Okay, makes sense? I'll be like, that does make sense because I'll just move this index. I'll keep it because this guy might match in future with these guys. Okay, but then you'll miss out on this C. I'm like, okay, let's check the other way as well. When I say, okay, listen, let's keep EC. That means let's keep index 1. Let's move C. Let's move index 2. I'm like, let's move index 2 here. Okay, makes sense. Now the C and C might match up. Now the C and C might match out. Why? Because of match on indexes. In the next step, E and D will go on match on indexes. C and C will go on match of indexes. And over here there's a plus 0, that's sure. But did you understand what I tried to do? I said, hey listen, if they're not matching, let's either move this or either move this. There's both the possibilities. I'm like, okay, does make sense. So can I say, if not match, then the answer added will be 0 for sure because there is no length that you are matching. Okay, plus f of index minus 1 is what you will go. Sorry, index 1 minus 1 is what you will go. And you'll keep the index 2. Or you will go, you'll keep the index 1 and you will go the index 2 minus 1. And you will take the max of both the guys. Yes, you'll take the max of either this guy or either this guy. And you can easily just move this or you can easily move this. And the max of this and this is what you will get the answer. Like either solve this guy or either solve this guy. Whichever gives you the maximum answer is going to be the max answer. Now, this is what if not match will be. So we have also explored all possibilities on that index. Take the best among them. You're taking the best among them. You either take on match, you either take this. And if they do not match, you take the best of this or this. So you've also done take the best among them. So that's how you can easily think in terms of DP on strings. I'll be drawing the recursion tree, don't worry about that. But that's how you can easily think of DP on strings. What about the base case? We will think about that. But let's try to write as of now the code in short and then I'll think about the base case. So I'll be like, okay, f of index, yes, f of index 1 and index 2 is there. That's for sure. Let's forget about the base case. What are the cases? Possibilities. Match or not match. Okay. So if they match, can I say if they match, then it will be index 1 equal to index 2. It can be. And what will be the answer? The answer is very simple. 1 of f of index 1 will also move. Index 2 will also move. And you can easily return them. So if this line does not, if this line executes, the program returns over here and it goes back. The rest lines will never execute. Remember, if this if executes, the program returns over here, and these lines will not be executed. So I'll write the next lines. What will be the next lines? The next lines will be very simple. I'll be saying either if this is not happening, thereby no match. If no match, can I say the answer will be 0 plus I will move the index 1 by 1 and I'll move the index 2 minus 1. Sorry, index 2 I'll keep it like this. Or I will be keeping the index 1 and I'll move the index 2 by 1 and I'll take the max of the best of them. And that's what I will return. If they're matching, it's fine. If they're not matching, then take the max of these couple of guys and return. So if I just write it in a sophisticated way, it will look something like this, like 0 plus 0 doesn't have any significance. This one not match, this one match. As simple as it can get. So that was about the possibilities. But what is the other thing that's remaining? That's base case, yes. That's something which is base case. Think about the base case. So can I say, when will the base case come? Okay, let's come back and see. When will the base case come? Can I say, I'm a T. At this portion, what will happen? You will say, I'll do plus 1 because this E matches with this C. And thereby, this index will go minus 1 and the other one will also go minus 1. But if this guy goes minus 1, it will go to negative because this was the 0th index. It will go to negative. And if it goes to negative, it's over. And similarly over here, this will happen. They are matching. So index 2 will go to negative. Index 2 will go to negative. This will become negative. Over here, this becomes negative because they've matched. So when you're comparing, either of index 1 becomes negative or either of index 2 becomes negative. What does negative signify? Let's write. Negative means end of the string. Negative means end of the string. Are very simple, guys. If f of 2 means string 0 to 2, negative will mean end of the string. So can I say, if at any moment index 1 is lesser than 0 or index 2 is lesser than 0, I can say it's the end of string. If it's the end of the string, what is the longest length? 0. What's the longest length? 0, guys. So I can say this is 0 and I can easily return. Either this goes negative or this goes negative. You don't have anything to compare. So the returning length will be 0. This is how the recursive code will look like. Now, in order to get more clarity, what I'll do is I'll take this example and try to do a recursion tree so that it gets clear on you, like on a crystal clear method. CED, okay? Where are we? We were here. Okay. What did the first step? What will the first step be? 1 plus. Perfect. And it'll call the function. So over here it will be something like 012, 012. The function call will be for f of 2, right? What will be the next function call? Plus 1 on f of 1, 1, which will be AC and CE. F of 1, 1 means AC and CE. So AC is here and E is here. Are they matching? No. So there will be two split calls. Let's do the two split calls. So if I do the two split calls, it will be plus 0 and f of 0, 1 will be one split call and f of 1, 0 will be another split call. Basically, you reduce 1 or you reduce this one. That's what you did, right? You either reduce this or you either reduce this. So a split of 1 of 0 or a split of 1 of 0 will happen. Okay. So what does this signify? 0 of 1. A, C, E, and this signifies AC and C. Perfect. We are standing over here, we are standing over here, we are standing over here, and we are standing over here. Okay. So this recursion will be solved at first, and then this recursion will be solved at first. You are understanding, right? F of 2, 2 will call f of 1, 1. F of 1, 1 will call this, and take the max of this and the max of this. So f of 0, 1, what will happen? A, E are not matching. Then they are nowhere matching. A and E are nowhere matching. So what will happen? Again, two split calls will happen. If they're not matching, two split calls. And what will be for the split call? It will go to -1, comma 1. What will happen to the split call? It will go to f of 0, 0. F of 0, 0. Understand, 0 is a split, 1 is, so basically you reduce. So over here, it gets reduced to nothing by CE, and over here it gets reduced to A by C. Why? Because you're moving this guy. So A by C is what it reduces to. Okay. Again, what will this return? Negative. This guy returns 0. A of C, if you go on solving this, what will happen? Again, two split calls. F of -1, comma 1 and f of 0, comma 0, or rather this will be actually 0. So f of 0, comma -1. Right? So this will also return a 0 because of negative. Because of negative, this will also return 0. So f of 0, 1 called those guys and it got 0 and 0. So this guy actually got a 0. So this guy will return a 0. Now f of 1, 0, what will happen? Let's analyze over here what will happen. C and C matches. So 1 f of both will reduce 0 and -1. So both will reduce. 0 will reduce to -1, 1 will reduce to 0 because C is done, C is done. So you move this to here and this is over. So 1 plus this, what is this? Negative. So this guy will return 0. So 1 plus 0, this guy's value is 1. This guy's value is 0. So f of 1, 1 called both the guys. One guy gave him 0, the other guy gave him 1. Which one will he take? He will take 1, the max of both the guys. Over here we had a +1. So +1 and +1, f of 2, 2 gives you 2, which is the answer. F of 2, 2 gives you 2, which is the answer. And eventually CD is the string, which is the longest common subsequence. So you got the answer. So you saw the recursion tree working perfectly and it did give you the answer. Very straightforward in all the comparison of string problems. If they're matching, you just take both of them back. And if they're not matching, you take either one string, you shrink one string, or you shrink the other string and try to do a comparison. And if you're able to do this, you can actually solve any problem on string comparisons if you can understand the movement of strings. Fine enough. So what are we doing as of now? We are actually doing recursion, and we know we are applying possibilities, right? So the possibilities, since you're trying out all the recursions, it's going to be 2 to the power n subsequences of this guy, to the power m subsequences of the other guy, because you're trying out subsequences. Like if you carefully observe, you are trying out subsequences, AC, you're trying out subsequences. 2 to the power n subsequence of the first string, 2 to the power m subsequence of the other string. So that will be like near about exponential, which is definitely something which we don't want. And we want this to be optimized. We want this to be optimized, correct? And how do you optimize this? You have to see if there are overlapping subproblems. Because if there are overlapping subproblems, we can apply memoization. I have already told you this in all the previous lectures. We can apply memoization. Let's see if there are overlapping subproblems in this particular problem. F of 2, 2 was there. F of 1, 1 was there. F of 0, 1 was there. F of 1, 0 was there. F of 0, 0 was there. F of -1. That's a very small set to see. But if you take bigger examples, you will see like these guys getting repeated somewhere over here, or similar. Like you can see over here, there is one state repeated. F of 0 -1 is repeated here also. You see both the states are repeated. Yeah, that's a base case. That's okay. But you will see if you take a bigger example, you will see states being repeated. You can take a bigger set of string and you'll see that the states are repeated. So what does f of ij state means? It says LCS of a string from 0 to I and a string 0 to j. That's what it represents, right? LCS of a string 1, 0 to I and a 0 to j. In this, they want the length. So if someone again comes up and asks you the same question, why do you want to pre-compute? Why do you want to recompute? Thereby, we can easily apply memoization. What is the technique to apply memoization? Look out at the changing parameters. One is I, the other is J. What is about I? It's N. What's about J? It's M. Thereby, you can say N cross M is what I will be requiring dp. So you can easily just declare a dp of N cross M, initialize everything to as -1, and you can just go back and add these lines over here. This is a return statement, right? So over here you can say, okay, fine, I'll write dp of ij equal to, this is a return statement. You'll say, okay, fine, I'll write over here, and whenever it enters, a very simple line of dp of ij is not equal to -1, and you return dp of ij. That's how you easily do it. That's what the function resembles. So it's time to check out the code. So we're given the string s and the string t. So really you can just give s dot size, right? And you can just give m equal to t dot size. Perfect. And right here you can say return f of, you can n-1, that is what we take, s and t. Perfect. Let's quickly write the function that we generally write. int f, int I, int j. Make sure you pass the string by reference, because every time if you create a new string, it might give you tl. This is what you wrote, this is what you wrote. Return 0 if they're matching, which is s of I equal to t of j. Then you're going to return 1 plus f of I minus 1, j minus 1, and an s and a t. And if they're not matching, you return the max of either both of them, like n I minus 1 j, s and t, or you just go 1, which is s comma t. This is how the brute force will look. And obviously you need to optimize this by applying memoization. So just apply memoization over here, which is dp of n cross vector of int and m cross -1. Please make sure you pass the dp over here. And once you pass the dp, right over here you can say vector of vector int and dp, and you just pass on the dp over here. You can just pass on the dp over here. You can also pass on the dp over here. Perfect. And what I can say is, okay, fine, the next thing that I'll do is memoize. So let's quickly memoize this. And as the last thing, you will just say, please check if the state has been visited previously. If this has been visited previously, kindly return it. And that's what the code will look like. Hopefully should run. Okay, it has some issue. Okay, dp was not declared in the scope. Okay, looks like vector has not been declared. So what it says is you have to actually use hash include bits std c++.h, because vector has not been defined. So you can easily define this, and after this I think it should be running fine. Fine, it runs. Now we're getting a 100 score. Now that's how the memoization technique will be. Now the next step will be tabulation, because we have to optimize the auxiliary stack space. And the time complexity in order to solve this by memoization was we go of n cross m, which we took in order to solve this using memoization. And the space complexity we took was n cross m for the states storage in dp. And then we go of n plus m in an auxiliary stack space, right? Now you might ask, why n plus m? I'll give you an example, a, b and c, d. I'll ask you to draw the recursion tree for LCS. If you remember, in match it was 1 plus, and in unmatch you moved in 2 directions. So this is unmatched, so you move in 2 directions, which is a by cd, and the other one is ab by c. Very obvious, because you either eliminate this or you either eliminate this. Again, over here you again move in 2 directions because they do not match. So you either eliminate a, which makes it cd, or you either eliminate d, which makes it a by c. Over here again in 2 directions, you either eliminate a or you either eliminate c. So if you carefully observe, 1 step, 2 step, 3 step, 4. So at max the depth is 4, length 2 plus length 2, because what we did was we deleted b, we deleted d, we deleted c. So alternative deletions. If you do alternative deletions, there can be n deletions from string s1, there can be m deletions from string s2. Thereby, the auxiliary stack space will go as n plus m. But obviously, as always, I'm not a big fan of n plus m. So I'll have to omit this. In order to omit this, I have to write the tabulation iterative bottom-up approach, whatever you can call it. Okay. So bottom-up. Rules I've already told you. What are the rules? Copy the base case. I've already told you the rules. Copy the base case. Second, write down the changing parameters in the opposite fashion. Perfect. Third, copy the recurrence. If you can follow these methods, I can guarantee that you can write any of the tabulations or bottom up for any of the questions. But copy the base case is a bit tricky over here. Why? Because if you remember the code was I comma j, and it was something like I lesser than 0 or j lesser than 0, and you return 0. So over here, this was the base case, right? If you remember, this was the base case. And in the base case, I can be negative. And usually we did see, yes, usually we did see in the recursion tree. If you remember the recursion tree, I'll just take you to the recursion tree that we did. In the recursion tree, the negative was -1, -1, -1. So we stopped at -1. So we can't write cases for -1 in base cases. Can you write for -1? Because how will you write dp of -1? That's not possible. That's not possible. So what we do is we do a shifting of index. Very simple. We do a shifting of index. We do a shifting of index in order to write tabulation. You can still write tabulation using this, but I want you to teach this shifting of index. In order to write tabulation, like without even shifting of index, I can still write tabulation, but that will be a bit tricky, so I'll not go that direction. Shifting of index. So as of now, there was index 0, 1, 2, like -1 was the negative index, 3 till on n minus 1. And we were calling these indexes, like how did the function start? The function call started from n minus 1 and m minus 1. And n minus 1 represented this index. F of 0 represents this index. F of 1 represents this index. Can I do a shifting? Can I do a right shift of the index? And I say, I will call n comma n. I will call n comma n. Yes, I'll call this. But over here I'll say, hey listen, n means n minus 1. Okay. F of 1 means 0. And f of 0 means negative. I shifted the index 1 right, 1 right. N means n minus 1. 1 means 0. 0 means -1. I shifted it 1 right. Okay, makes sense. So if you're shifting it 1 right, so can I say f of ij? If you've shifted ij, like initially I is n and j. Initially I is n and j is m. You've shifted it. N is actually n minus 1. 1 is actually 0. So can I say, that means every I that you're giving should be treated as I minus 1. And every j that you're giving should be treated as j minus 1. Because that is the meaning. Because as of now, you're sending I and j in terms of one shifted index. I'll be like, does make sense. Does make sense. So can I say, instead of greater than 0, can I write this as I equal to 0? Because this signified I equal to -1. But since I've shifted it, can I write I equal to 0? Yes. And can I write, instead of this, j equal to 0? I can. The base case has been changed. If I take you back to the code, over here, instead of n minus 1, I can write n. M minus 1, I can write m. And over here, I can write equal to. And in the j also, I can write equal to. But what's the other changes? Everything stays same. States being called same. You're doing a string comparison. But I means I minus 1. J means j minus 1. Changed. And now if I run this code, does this run? Same. It will. Why will it? Because you've just shifted it. Okay, it's giving runtime error. Why does it give runtime error? Because the DP that you've declared is of nm, and you're now using the states of nm. So just make sure you declare a DP of extra size m plus 1. And now, You've done a shifting of index 1 right, and it does work fine. So, okay. So the base case has been, now the base case is changed. What is the base case now? The base case is now very simple. It states if I is equal to 0 or j is equal to 0, we are returning 0. How can I write this in simple layman terms? Okay. What does I equal to 0 means? It means any dp of 0, and this guy can be anything because this is j. J can be anything. And what does this mean? I can be anything, but this guy has to be 0, right? And what can be the possible values of j? Anything from 0 to m minus 1. What can be the possible values of I? Anything from 0 to n minus 1. Loop it. The base case are very simple. J can be anything from 0 to m minus 1, and dp of 0 and j will be 0. This is for this one. And for this one is this. I can be anything from 0 to n minus 1, and dp of I comma 0 is equal to 0. Base case written by shifting shifting indexes by 1. Base case has been written. Perfect. What's the next? Write down both these guys in opposite fashion. Okay. So the moment I shifted it, the recursion was taking I from n to 0 and j from m to 0. Top down, these are the base cases. What is tabulation? Bottom up, you go up. So 1 to n. Why not 0 to n? Because 0 is the base case which has already been written. So 1 to n. What about j? Opposite. Done. Next, copy the recurrence. What are you waiting for? Just go back and copy the recurrence, and you'll be able to easily write the tabulation format of LCS easily. So what I'll do is now I'll go back and try to write the tabulation format. Okay, so we have this guy. That's perfect. Let's just format this and try to write this. So if you remember, it was I equal to 0, or rather, yeah, j equal to 0 was the first one. J equal to 0 and j lesser than m. But then now it will go j this dp of 0 and j is 0. Perfect. And similarly, I can go as 0 till n. I can go as dp of I and 0 as 0. Perfect. And similarly, for loops can go as and I equal to 1, I lesser than equal to n, I plus plus. Similarly, the j loop can also go in a similar fashion of I and j equal to 1, j lesser than equal to m, j plus plus. And you can just copy paste. Yes, just make sure you copy paste the same thing. Just instead of written, just remove written. Yeah, just remove written. And just copy paste the same thing, exactly same thing. And over here, just return dp of n and m, and remove this. And what you can do is you can also remove this portion, and instead of f, just make sure you write dp of I minus 1 j. Perfect. And over here you can write max of dp of I minus 1 j, and again you can just remove this portion, and the comma of dp of I and j minus 1, and again please make sure you remove this. Yeah, and that's what it will be. So if I now try to run this, probably should run if I've not done syntax mistakes. Again, the hash include missing. Okay, it's giving us a wrong answer. Why is that? So we'll check out why is this giving us a wrong answer, and then we'll get started. So why did this give us a wrong answer? Because in the recursion, if this if executed, it went back from there. Over here, you have to just make sure you write an else. Okay, just make sure you write an else, because it will not return. In recursion, this line was not executed. In for loops, it will be so. Just make sure either it is matching or not matching. It is running fine. Now you can just go across and submit. So can we do space optimizations? Yes. I have always told you, if there is a scope of I minus 1, which means previous row, I minus 1, which means previous row, you can always, I repeat, you can always space optimize the same portion. So what you'll do is, instead of this, just make sure you have a previous of m plus 1 comma 0 and a cur of m plus 1 comma 0. Perfect. And over here this will go as, this is the 0th guy. So what I'm basically saying is, okay, for any 0 what will happen? So this is dp of 0, right? So you can say previous, and will this be there? Will the column be there? No, there's no need of column. So you can just omit this. For the first row, everyone is 0, right? So that's what you've done. Over here, just make sure instead of dp of I minus 1, that's previous. Over here, just make sure instead of dp of I minus 1, it's previous. Over here, this is fine. Instead of dp, it will be cur. dp of I, it will be cur. Just make sure it is cur. And over here, instead of dp of I, this will be cur. Instead of dp of I, this will be cur. Perfect. And just right after this, you will do cur equal to previous. And over here, you'll just return the previous guy. Or cur, whatever you wish to. Is this fine? Yeah, this should look fine. So now you can try submitting this, and you will see that this is also not running fine. Why? Okay, forgot to have a colon. Okay, so if I give a colon, simple, just previous column, previous cur concept, and okay. So the issue was previous equal to cur will be here, not cur equal to previous. My bad. Okay, so if I just give it a submit, I should be running fine now. Yeah, should run. If I give it a submit, this will definitely run. So guys, I hope you have understood how I took a memoization solution. And since we were having problem in tabulation, I shifted it by right so that we do not have negative integers or negative indexes in base cases. And after that, I just simply converted that into a tabulated. Once I converted that into tabulated, the space optimization is an extension of whatever I've taught in the previous DP lectures. So if you haven't seen the previous DP lectures, it's your you should definitely go and watch it, because you're missing on space optimization, which is a very, very important trick. So guys, I hope I was able to make you understand LCS. Just in case I was, please make sure you like this video. If you're new to this channel, please do consider subscribing, and yeah, to continue our tradition, please make sure you write understood in the comment section. And with this, let's wrap up this video and meet in the next one. Till then, bye bye, take care.